Next on the stage is Matt Welsh. He's the CIO for X Energy. And Matt is another friend of mine, super smart guy, and I think they picked the right guy, X Energy did, to help lead them through one of the most exciting times in the history of power generation. And I wrote down in America, but I think the world. So X Energy is charting the nuclear future, and AI is a powerful tool in that journey. So please join me in welcoming Matt Welsh to the stage.
Good morning, everybody. Great introduction. I was set to give my intro, but he already did it. And what I would say is I'm sort of a walker, so I asked for the handing mic so I didn't have to be locked behind the podium. I graduated in 2001 from the School of Pamplin, Business Information Technology, and it's just an honor to be back here today to talk with you all today. And thank you for taking the time out of your day to come listen to this, all the information that's happened. It's a really exciting time. There's so much going on with data and AI that I feel like the best way to encapsulate it for me to you today is a descriptive model rather than a prescriptive model. Anybody who really feels like they've got it all understood, trying to tell you how to use it, I think is really missing the point that right now we are in a sort of an age of discovery with AI, and a lot of organizations aren't exactly sure how to use it. So I've taken the descriptive approach, meaning I'm going to tell you why X Energy is here. I'm going to talk about X Energy as the company itself overall, what we do. I'll talk about our data, I'll talk about our AI solution, and then more importantly, how I'm building a team that's going to build that solution and make a difference for X Energy's mission. So let's get right into it. Why does this matter? On the right-hand side of the chart, you'll see that an AI search or an AI query, or AI command, is about 10 times more intensive than a regular Google search. And while AI may be the new electricity, as my previous speaker said, I'm here to talk about the old electricity, which is just actual electricity. The growth of AI is going to stress our power grid and our power demand. It's going to stress the data center construction. If you look at even data center locations for the past 30 years, they've been focused in areas where the grid had resilience and they were close to power. If you're able to decouple data centers from power sources, or even have data centers bring their own power sources, it can really change humanity and change our country drastically. These large AI facilities will now become a resource not just for compute and information, but also for clean, reliable power. And they can provide that extra power back into the grid. So while right now we see a lot of headlines that data centers and AI are certainly taxing the grid, what I think you'll see is that overall the solution, both AI as well as nuclear power, will provide a resource that'll help everybody. X Energy, in simple terms, we design and build nuclear reactors, and we build fuel that powers them. Specifically, we're building the XE100, which is the graphic on the left. It's a high-temperature, gas-cooled pebble bed reactor. Don't say that 5 times fast. It is about 2.5 stories tall. It'll be factory built, and all of the parts will be able to be put on the back of a truck and trucked on site. The little sphere there that you see is a triso pebble. I'm an IT guy again, so I've had to come up with simple ways to explain nuclear technology. So the pebble is low-enriched uranium nerds, about the size of a candy, inside a graphite gobstopper, and about the size of a billiard ball. And if you want to carry the candy analogy further, it sits in a two-story tall gumball machine. And the pebbles actually come out every couple of minutes for inspection and to see what the fuel levels are for those pebbles. Based on its design, and there have been high-temperature gas-cooled pebble bed reactors. The Chinese have a working version of this reactor already. There's been a version in Germany from the 70s. This is proven science. It's just a matter of us commercializing it and bringing it to scale within the US. We also, our fuel facility I mentioned, we also have a space application, eventually putting one of these on the moon for fission space power. So let's look at some pictures, easier way to tell you what we do. Our first project is with Dow. It is outside of Houston, Texas. Dow has an industrial chemical plant. Those chemicals are used in the renewables industry for plastics and rare earth metals. They require high temperatures in order to perform the metallurgy and chemical transactions that they use to produce their chemicals. Our original use case, going back 3 or 4 years ago, for our reactor was to be clean industrial heat. I would jokingly say you won't get a solar panel to 600 degrees Celsius, right? So we put out steam that can be used for industrial heat. Industrial heat creates 25% of the world's CO2. So our first project is underway with Dow. We've done core samples. We've got pylons going in the ground. So in a few years, you'll see this plant open up. It'll be the first advanced reactor facility outside of China. Our second project was just announced a few weeks ago. It's in the state of Washington, fully funded by Amazon. I'll talk more about that partnership in a minute. And that is a 12-pack of our reactors to power a data center and an energy facility. Obviously, Amazon has a lot of facilities in the state of Washington, and they want to provide clean power and funding to help produce energy for not just for their data centers, but also for the community in the state of Washington. Our fuel facility is under construction now. Vertical construction started a couple weeks ago. We're hoping to be done with vertical construction sometime in May of next year. And that's where we will turn out those nerd gobstoppers. Each reactor needs 200,000 of them. So, and they need every 5 years, they will sort of be filled up. So we've got to make a few million of these pebbles. We've been operating a pilot line at Oak Ridge National Laboratories for about 15 years. So we've got a proven science. We just need to, again, take it to an industrial scale. Amazon was our Series C1 round funding last year, which was fantastic. It's created this partnership that's permeated into the IT department. And as the CIO, it's been amazing to work with them. I'll let you read more about this, and we can talk a little bit more about the data aspects as we keep moving forward. This was announced last month. We now have a partner in the UK for up to 6 gigawatts of deployment as well. So as you can see, this company has sort of a relentless pace and huge ambitions to help bring clean baseload power that's directly associated to our ability to deploy AI solutions within the United States. So let's talk about the data. We are a startup, which has blessings and curses that come along with it. But it means that we're a digital native. I don't have to deal with COBOL code or 8 different types of databases or modernization of .NET code. We're just cloud native, and we're going to be AI native as well. The graphic you see here represents our efforts for digital engineering. So at Virginia Tech, you've got a lot of engineers probably that are peers of yours, maybe a few in the room. So electrical engineers, mechanical engineers, nuclear, all of those folks are using tool sets to create digital artifacts. And we're basically borrowing the best practices from companies like SpaceX, GE, and Boeing, and applying those to an industry that hasn't built anything in the US for the past 50 years. If you look at every reactor, there's about 90 reactors running in the United States. All of those are generation 1, we're at generation 4. So the analogy is, imagine if they skipped from the iPhone 1 to the iPhone 10, but we just stopped building 2, 3, 4, 5, 6, 7, and 8, right? It's time to start building the new stuff. But in so doing, we're sort of creating this culture clash between aerospace engineers and nuclear engineers, which have been more construction focused. So this really is on the front end of the tip of the spear of innovation is getting people to adopt new tools and new behaviors. So it's quite interesting, quite challenging. But in this life cycle and in the use of these tools, we create a significant amount of data. So let's take a look at what the structured data looks like. Again, I am an IT, I am not an engineering major. So your engineer friends will probably know exactly what they're looking at here. But what you end up with is a computer-aided design, a series of tool sets that create a metadata field of configuration control. If there's any software developers in the house, think of it like code branching, but it's for an engineered product. It's a physical product. The tool sets are called product lifecycle management. On the left-hand side of the top, you see the main power system. We've got the spherical unloading machine. That's the gumball machine bottom. And then we have a fuel handling system that evaluates each pebble as it comes out. On the bottom, we actually run a series of analysis off of those CAD models. And probably too small for the print here, but we have some models that have 1.2 billion cells. And we're trying to evaluate it from everything from structural integrity to gamma radiation, to metal morphing over the years under pressure and under temperatures. So this is some of the structured data that we have access to, and it's still pretty early days for us in some of these areas. For the unstructured data, well, we've got a lot of that. When you move from a preliminary design to a detailed design phase, for us at least, you're going from a lot of paperwork, a lot of documents into detailed design, into actual things that you can 3D print, is how I would summarize it. So on the right-hand side, you'll see we've got over 3,000 PDFs that encapsulate the description of our product and the different systems that it takes to operate. And we've paid scientists for decades to pull this stuff together. We have parameterized inputs, we've got requirements, we've got material selections, and here's why it needs to be this type of steel. It's all embedded in unstructured data. Now, is there any tool that you can think of that would help me mine that data and pull out parameterized information and check it against my CAD and PLM tool? Right, so here comes AI. Our AI solution that we've deployed is called Max. It's running in an environment that we call Apex, and it really goes along with the previous presentation. That was a wonderful presentation from AWS. We're thinking of AI as really the backbone or the operating system for everything that our company does. So all applications we build in the future will either be AI native or have an API-based integration into Apex. Max then allows for a multi-agent approach where we can then mine that information and then have direct API calls into our engineering platform so that we can manifest our design into a detailed design rather quickly. We're looking to get into detailed design as soon as we can. 11 gigawatts is about a little over 100 reactors, roughly $1 billion each. So we've got a big market opportunity ahead of us. I can't talk enough about the AWS partnership and as an accelerant for what we've been able to do. We've seen, if you're in IT, you've seen the difference of cloud and it's made in our lives over the past couple of decades. It's just magnificent that these companies can manifest themselves so quickly. With our AWS partnership within the GovCloud, we were able to basically have the most secure environment that can house all of our nuclear secrets, all of our intellectual property, and it's inherited immediately with AWS Bedrock. The LLM models are then there for you in sort of a menu, and you can just pull them out and instantiate them. We did build some of our own knowledge-based libraries, as well as an identity management inheritance, so it'll actually know who you are and what applications you have access to within the enterprise. So we had to build some of our own bespoke modules within the solution. But having a starting point with Bedrock and then our partnership with Anthropic has really accelerated Max, and to go from sort of a concept to a go live in less than 90 days, knowing that we have all the inherited security controls that the NRC and the DOE want us to have, has truly been game-changing for us. So here's a quick screenshot. I'm telling you a story with pictures today, but this is what Apex looks like. We've got some interesting community features here, which are actually monitored by the AI agent itself. So natural language processing users can request features. It'll evaluate those features against a backlog that we already have. So if it knows that your request is related to something else, it'll actually add points to that. So we have sort of an AI governing our backlog and our feature sets to allow us to continue to add capabilities. It's still early days. This AI agent went live roughly 3 months ago, but we've had significant amount of use. We've got some success stories, which I can talk about here when we get to the use cases as well. As the CIO of the organization, I have sort of the gas and the brakes. It's very challenging to know when to put the brakes on. I'm more of a let's go fast kind of a CIO. So we had people using ChatGPT until Max went live. I gave it a couple of weeks, and then we blocked all access to public AI models. And I was not the friend of the rest of the organization that day. But what I did find out, though, is that sometimes the user is not the best categorization of security data. So we had people using public models when they probably shouldn't have been. But we were a young company, and we needed to move as quick as we could, so we were able to take that risk. So as people came to ask for exceptions to the public models, sort of saying, hey, what are you doing with that? We started to ferret out a lot of misuse of public models. So now happy that we've got it secure and we've got it within our own confines of our own organization. We've talked about use cases. On the right-hand side of the slide is actually a portion of the use case list that the cohort did last year for us. So the Virginia Tech CBA cohort actually went out and interviewed all of our business stakeholders and came up with this opportunity framework for all the ways that we could use AI. Some of the ones that sort of jump out for us is licensing. The NRC has a licensing process for all nuclear technology. It's roughly a 2,000-page document, right? And in that 2,000-page document, we sort and we reference metadata or parameters that are being developed by our engineers. So we're able to build this sort of taxonomy and into the document so we could track changes for it, which I know sounds like an easy use case, but to have an army of engineers doing that right now, our licensing team is probably 20 or 25 experts, but now to throw AI at it, we should be able to accelerate the time it takes to develop a license and to respond to NRC comments. There's a whole host of other ones on there. Apologize, this font is way too small. But there's a whole host of opportunities, and really then it's about how do you choose which solutions and which use cases to use. Our AI lead, we were able to find him out of the Department of Energy, a PhD from MIT, computational science, and also a nuclear engineer. So he now has, and it's a team of one, right? So we have no other software developers. We should have a team of 15 by this time next year. So we're ramping up our staffing and building, and I'll talk more about the team formation here in a little bit. But how do we choose what to work on out of the backlog? Really, I think it starts on the right-hand side, which is our business impact. We are a pre-profit organization. Right? We are a startup, so whatever it takes to get our product to the market sooner and to generate meaningful revenue is what we should focus in on. So business impact obviously is number one. Ease of implementation, we want some quick wins. We want to find some use cases that actually inform our use of the tool and also help other people adopt it and understand how to use it. Cost savings or time savings is something we're looking for. And then whether the data format is structured or unstructured is also some of the decisions that we're looking at. So for the team build out, we are taking a product management approach, which is probably a little more standard in the industry today, but that will be a team of multidisciplinary individuals formed together, along with an embedded engineer from each of the departments. So we'll have mechanical engineers, electrical engineers, nuclear and radiation technicians embedded with their own development team. What's very interesting is this is not yesterday's development team. So we're looking for developers who are able to take AI and to use it as a force multiplier. In theory, the development team, because we don't have them yet, but we will be hiring them. In theory, they will be spinning up hundreds of agents, right? And you'll have a team of agents for requirements, a team of agents for functional testing, a team of agents for development, right? So a team of 3 or 4 developers should be able to spin up an agentic team of 300 developers, right? So we should be able to attack this backlog in force quite quickly, which is why the product management approach is so important, is understanding what the end user is looking for and what the value proposition for is the main thing. So as you're looking to figure out from your careers what you should do, I've heard articles about software development's going away. It's not. Right? If you speak the same language as the AI tool, you're a leg up over everybody else. So I would just echo the previous speaker, lean into it as much as you can. We have a cultural change right now where I've got people in the industry that have been professionals for 20 and 30 years, and they're scared of AI. They're reluctant of it. So we really need you all to be the innovative change agents that we expect you to be. And when you enter the workforce, that's how you should come in, is you should be different. We have a generational shift happening, and that's what we want from you all when you come into the workforce. I'll leave you with a more complex thought that we can talk about either in breaks or other areas. But as you think about AI as a fabric for software development, and as the CIO, we probably spend $20, $30 million a year on software. I think SaaS industries and SaaS software is under attack from AI. I think there's a lot of bespoke software tools that are connectors or that are visualizations, that are data aggregators, and I think those will be subsumed by AI. AI will overtake those. We are a fairly new organization, so I'm still putting in place some of the larger building blocks of an IT enterprise. So we didn't have an HR system when we started, so I had to put that in place. We don't have an ERP solution. We don't have a CRM solution yet. So I've still got those basic building blocks to put in place, and I think those will be fine. The SAPs and the Workdays and ServiceNow, I think those orchestrators will still be there. But all of those other mid-tier software providers, I think will end up, at least for our organization, end up being a microservice that exists within our own platform. And we'll be able to orchestrate that data, visualize that data, and act upon that data without having to pay for proprietary SKUs or proprietary connectors across different products. So that's a more complex topic. I'd be happy to talk about that more in the breaks. It's, again, been an honor to talk with you guys and look forward to any questions you guys might have in the networking sessions. So thank you.